Today's problem was submitted by a viewer, and it says, let ABC be a triangle with angle A is 90 degrees and AB is equal to AC. I guess this means the lengths of AB and AC. Let D and E be points on the segment BC such that BD to DE to EC is equal to 3 to 5 to 4. Prove that the angle DAE is 45 degrees. Okay. These types of geometry problems I often find I struggle with, but I'm going to see if I can work through this one. So I believe we have a right angle isosceles triangle. Oops. Why is this being funny? Okay. What's going on here? Just draw a line, please. There we are. So we have a right angle here. We have points B and C. AB is equal to AC, so these lines are the same length. Let D and E be the points on the segment BC. So D and E lie somewhere along here, such that B to D, D to E, and E to C is 3, 4, 5. So let me just mark points like this. Doesn't actually say that D and E are in this order, but I'm going to assume for now that they are. And we're given that B to D to D to E to E to C is 3, 5, 4. So I'm just going to label these lengths as 3, 5, and 4. Just assume that those lengths are given like that. And so we don't actually know what the lengths of AB and AC are. Or no, we do, right? Because this distance is 12. And so this is going to be 12 divided by root 2. This will also be 12 over root 2. And we want to show that angle DAE is equal to 45. So we're going to have a line like that, another piece like that, and let's call that theta. We need to show that theta is 45 degrees. Make sure I've incorporated all the information here. Angle A is 90. AB is equal to AC. Okay. I mean, we know that this is 45. Let's call these angles both alpha. So we have two side lengths and an angle. In theory, that allows us to compute the length of that side. We have the same thing over here, two side lengths and an angle. In theory, we can compute the length of that side. Once we have the length of those three sides, we can compute that angle, in theory. We'll need some trig ratios and all that kind of stuff. Or what is it, mostly cosine law it looks like that we're going to be using. So let me try and remember what the cosine law is. I think it's y squared is equal to x squared plus z squared minus, is it 2xz cos beta? I mean, when beta is equal to 90 degrees, this becomes the Pythagorean theorem. When beta is equal to 0, we would have y is equal to 0 and x and z must be equal to each other. I think this is the cosine law. Okay. So if we just put this all together, let's call this length x and this length y. Then using the bottom triangle, I have x squared is equal to 16 plus 144 over 2 minus 2 times 16 times 144 over 2 times cosine of 45 degrees is pi over 4. Cosine of 45 degrees is also 1 over root 2, right? Should I simplify this all? 16 plus, plus 72 minus 16 times 144 over root 2. $88 root 2 minus 16 times 144 over root 2. Multiply by root 2 over root 2. 88 times 2 minus 16 times 144 root 2 divided by 2. So x squared is equal to 88 minus 8 times 144 root 2. This number looks negative. Did I? Oh, I squared something when I shouldn't have. Backtrack. A lot of mistakes here. Let's just redo all this part here. Sorry. 2 times 4 times 12 over root 2 times 1 over root 2. Okay. So I have 8 times 12 over 2 . So x squared is equal to 88 minus 48, which is 40. Okay, so that's x squared. It's equal to 40. Now let's do the same thing for y squared. Y squared is equal to 144 over 2 plus 9 squared. Or sorry, no, just 9. Minus 2 times 3 times 12 over root 2 times the cosine of that angle, which is 1 over root 2. 72 plus 9 minus 3 times 12, so y squared is equal to 81 minus 36. Y squared is equal to, let's see, 51 is 55. No, 45. Is that right? 81 minus 6 is 75 minus 45, yeah. Okay. And now let's put in the cosine law for the last collection of numbers. We have 5 squared, so 25 is equal to 45 plus 40 minus 2 root 45 root 40 times cosine of theta. Why am I so bad at addition today? Minus. Is there an easy way to mix up these roots here? 45 is 15. That's 9 times 5. 40 is 4 times 10. Okay, so I have 2 times 3 root 5 times 2 root 10 is times cos theta is equal to 60. Okay. Let's divide both sides by 3. So I have 4 root 5 root 10 cosine theta is equal to 20. So I now have 5 root 5 times root 10 cosine theta is equal to 5. Root 10 cosine theta is equal to root 5. And this gives cosine theta is equal to root 5 over 10. Cosine theta is equal to square root of 1 over 2. Cosine theta is equal to 1 over root 2. And this means theta is equal to 45 degrees. Yeah, so just crunching through all the computations. The only sort of important piece of mathematical knowledge I suppose I used here was the cosine law. Use it 3 times, once on each of the smaller triangles. And that essentially set up a bunch of equations for the 3 unknowns, x, y, and theta. You know, it was obviously also useful to recognize that we can just, even though we were only given the ratio of these side lengths, we can just declare that that's what they are, because you know, if we said that the length of this whole thing is x, or well, I've already used x. Say the length of this whole thing is capital L, then this is going to be capital L times 3 over 12. That's going to be capital L times 5 over 12, and that'll be capital L times 4 over 12. And everything would have worked out exactly the same way, but you just have factors of L coming out of everywhere. So it's basically without loss of generality we're saying this, and we're looking only at angles, so scaling things up wouldn't have changed any of the angles. Yeah, so apply the cosine law a few times, and we ended up with our answer. Maybe there's another way of doing this that I didn't see or didn't think about. It'd be interesting if someone points out an alternative way of solving this question. Thanks for watching.